Hello everyone. I will be solving this problem called SUBARRAY product less than k of today's LeetCode challenge of September. So let's go to the problem statement. It says count and print the number of contiguous subarrays where the product of all elements in that subarray is less than k. Okay. So we will be given with a array like this 10, 5, 2, 6 and a value of k, and we have to find out how many contiguous subarrays are present in this array which have product of them less than 100. So it has total 8. So what are the 8 subarrays? We can see it's 10, 5, 2, 6. All the individual elements are less than k. So they will obviously be a subarray which having product less than k, which is in case 100 over here. And 10 into 5 is 50 less than k. 5 into 2, 10 less than k. 2 into 6, 12 less than k, and this also less than k. But over here we can see that 10 into 5 into 2 is not included in this product because it's greater than or equals to 100, because 10 into 5 is 50 into 2 is 100, which is in this case equals to k. So it must be strictly less than k, then only we can include it. Okay, so after going through this problem we can see there is only one example given, because the problem statement is pretty straightforward, because it's basically asked we have to count the number of subarrays which are less than, which has the product of all the elements less than k. So there is no need for many other test cases here. So now let's go through and see how we can solve this problem. This is basically a very good example of a two pointer approach problem, because we can solve this problem using 2 pointers. Like we will be having a pointer at start and a pointer at end. So let me open up my notepad and let me just quickly run you through this example and how the 2 pointers are actually working in this example, so you can clearly understand. So over here I'm pasting this example, like nums will be this and our k value will be this. So we will be having 2 pointers, like start will be having 0, and similarly we will be having end as 0. So we will be having both these pointers pointing at this initial index initially. So let me just quickly write down the index of these values also, like 0, 1, 2 and 3. Okay, so first of all what we will be doing is we will be also keeping track of, let's call it current product, and which initialized will be with 1. So whatever element we are encountering at the current position, we will be multiplying it with the current product, and we will be keep on multiplying the elements until and until we reach like 100. Until it's less than 100, we will be adding that subarray to our answer. But whenever we hit more than 100 or 100, we need to delete from the beginning, like from the start, like any other 2 pointers problem. So let's see how this problem is panning out to be. So first of all, the current product is 1. The first element end is over here, so we multiplied this 10 with 1. So now our current product is becoming 10, so which is indeed less than 100. So we will be adding the, let's call it max length, which is indeed first 0, then we add it to our answer, it's now 1. Now the end is incremented to 1, so now the end is over here. So this element at 1th index is now added multiplied with this, so it becomes now 50. We again see this 50 is less than 100. So now here's the interesting thing, we have to keep note of that this 5 and 10, this both forming one subarray which is less than 100, like which has multiplication less than 100, and also this 5 which is an individual subarray also which is having a product less than 100. So at length 2, total how many number of subarrays we are having which has product less than 100? It is these two elements individually, so 2 plus these two combined, so 3. So this means what? Whatever the value we had before, it is incremented by the length of the current subarray, because up to this one we have 3 subarrays, so we had already 1, so now incremented by how much value? its length. So now it will be incremented by 2. So now it becomes 3. So until this point our answer is 3. So now again we multiply this one. So when we multiply this one, now our end will be 2, and we see our current product now becoming 100, which is equals to k. So that means what we have to now like divide, or let's say we can call it also remove elements from the left or the start pointer from here. So we will remove or like divide elements from the start pointer until and unless our this current product variable again comes down to less than 100. So first of all we decrement, or sorry, divide this 100 by 10, so it becomes 10 again, and we increment our start. So now it's 1. So after that our start is pointing over here and our end is pointing over here, this 5 and 2. Here also we can see there is two subarrays forming. One is this one, another is these two together. So that means once again we are taking the length of the current subarray which we are having. So 3 plus 2 once again, so our max length is 5. And if you also check, like up to this index, our total value is, total number of subarrays which are having less than k product is also 5. Like all these three, each element once, then this two 1, so 3 plus 1 4, and this two 1, so 4 plus 1 5, so total 5. So now again we increment n to 3. So now this will be like 10 into 6. So now our current product is 60. So again it's less than 100, so no issues. Now we have the length is 3, so we have to add 3 to our answer, so our answer is 8 now. So I don't think I have to again explain like why we are adding 3 over here, because this 6 itself is a subarray, this 5 2 itself is a subarray, this 2 6 itself is a subarray. So we have to encounter all these things, so that's why we have to add this whole length to the previously encountered length, which was 5 there, and plus 3, now 8. And if we see over here, the answer is 8 also. So this is our whole algorithm, and this is how we should write our code. So before that also we have to note one thing here, that let's say the value of k is 1. So what will happen if the value of k is 1? Can there be any subarrays which are having multiplication or like value which are having less than 1? Because whatever the default value of our multiplication is, we are initializing this with 1, because 0 into something is 0 obviously, so we have to initialize it with 1. So the minimum value itself is 1, so there cannot be anything less than 1. So if our k value is less than equals to 1, we by default return the answer 0, because there cannot be any subarrays. So it will be like a base case over here. So the first thing which we will write is, if k value is less than equals to 0, we will simply return 0, or else. Now the real code begins now. So we will be initializing our answer, let's say call it max len is 0, and at the end we will be returning it like this max len, and in between we are initializing two pointers, let's say start, another is end, so both will be at 0th location. And we have to also keep track of current product, so current product will be 1. So as I've said, we will traverse until this end reaches the length of the given array nums. So we will be keep on multiplying whatever the value is at the end index. So it will mean what? Current product into equals to let's say nums of end. So we are multiplying the end. So now here we will check if by chance any case this current product is getting increased or getting larger than k, then we have to decrement from the left side or from the end of start, so until or unless it's again becoming less. So that's why we will be having again a while loop inside it. So here we will be checking until the start is less than equals to the end, like the start or end is, they should not just overlap each other. It should overlap, it can overlap, but it should not cross each other, like end will be before and start will be after it. It cannot happen. So that's why we are doing this check first, and also we are checking unless and until our current product is greater than k, this loop will again and again go on. If it's less than k, then it will be terminated. So that time what we will do, that time we will be dividing whatever the value we have at index of start, and we will be like closing in the window. So that's why start plus equals to 1, like we are incrementing start from this left side, so that's why start plus equals to 1. So after that, once this is done and we make sure that the subarray which we are considering right now is having product less than k, then we have to add the length of that current subarray to our answer, as I have already shown you, like why we are adding the length of it, because these single elements also should be considered as one subarray. So that's why. So max len will be plus equals to, how do I calculate the length of one subarray? Let's say we are at index 1 and start is index 0. So what is the length? Length is 2. So how do I calculate it? It's end minus start plus 1. 1 minus 0 plus 1, it's 2. So we see the subarray length is 2. So we will be doing that one here. So end minus start plus 1. So it will be incrementing our max length variable, and after that we will keep incrementing the end over here. So this will be our code, and let's see now, run this code and let's see if we are getting any errors or not. I think we won't. So 8 is 8. Okay. So then now just submit it and let's see if it's working or not. So we see it's accepted. So now let's talk about the time and space complexity. The space complexity will be obviously big of 1 because we are not using any extra space, and the time complexity will also be big of n because we may have two nested loops over here, but at the end of the day what we are doing is we are having two pointers which are completely traversing this array only once, like it's a linear traversals, the start and end. We are traversing end to the end of this array and start also just before the end. So the two pointers are traversing this whole array only once, so that's why it's linear also in time and constant in space. So this is how we have to solve this problem of today's challenge called subarray product less than k. So hope you like this video, and if you found this video helpful, please make sure to like and subscribe. Thank you for watching.